In the previous session, we saw questions of this form where we were able to get the limit of these functions, right? So what the major thing that was actually regulating most of the things is the number that is here. Here is 9, right? Yeah, we look at this in the same question. But then I wanted to look at a special case where it's no more approaching a number, but then they say it is approaching infinity. It may be positive infinity or negative infinity, any of them. All right. Once it approaches infinity, then the dynamic of dynamic of our method changes. So how do we solve such case, right? So now what we have to do is that for such a case, they usually give it for functions that are like fractions, like this one, functions that are fractions, like this one, right? Rational functions usually. So for such a case, what you have to do is that you have to look at the denominator, right? Look at the denominator. So we are talking about x as the independent variable, right? So the denominator, the independent variable is x, is here, is located here, right? It's nowhere else, it's located here. Okay, if there are multiple of them, let's say we have s squared minus 3s plus 81 as the denominator, then you see that we have x here and x squared over here, right? So what you do is that from the bottom, right, we take the variable, the independent variable that's having the greatest power. So here, this one is to the power 2, and this x here that's attached to the 3 is power 1. But then you have to take the one that is having the greatest power from the denominator. Remember, here, first step is look at the denominator, focus on the denominator, and pick the independent variable that is having the greatest power. Here, looking at this our denominator, right? The x squared is only one there. There's no competitor, so there's no competitor for it. So it's only x squared. So the denominator is the greatest power of the independent variable, which is x, is s squared. So what you do is that you go right, both the top, the numerator and the denominator. You pick that greatest power of the independent variable. Then you each term so at the top and at the bottom, you divide it by that particular value. So you have at the top, you have x over s squared, right? Minus 9 over s squared. You take each term should undergo the division. Even the bottom has one as well, s squared over s squared, right? Minus 81 over s squared. Then you just do simplification. X over s squared, that will give you what? 1 over x if you simplify that one. Minus this one will not give you anything, s squared. Denominator, it will give you 1 here, right? Because s squared over s squared will be 1 minus 81 over s squared. You cannot simplify it. Now, after you do the simplification, now wherever you see x or s squared or any component of x as the denominator under any of the term, make the whole thing 0. What I mean is that if you look over here, after doing the simplification, we are seeing that for this particular term division, after doing the division, x is at the denominator of this term. If x is at the denominator of that term becomes 0. The thing is that the basic truth is that the denominator should not contain of each term. After the simplification, the denominator of each term should not contain x. So here, each term is now, this guy is also having an s component, sq or something. So minus 0. It's also having 0 all over 1 minus 0, because this guy is also having s squared at the bottom. All those are to at the end of the day, we have 0 over 1, and 0 over 1 is equal to 0. So the limit as this approaches infinity is 0. Now this is the answer for this. Okay. Let's go through that again. We look at it because it is an infinity, right? If it is about infinity, look at the denominator. Be the greatest power of the independent variable. In this case, our independent variable is x. I'm saying independent variable because sometimes it may be t, it may be s, it may be q. So independent variable, focus on how do you find the independent variable. You see the value here. They say x, so that variable will be the one. So you pick it from the denominator. When you pick it from the denominator, right, you take that value, you do justice to each term. So you look at the top, every member of the function, right, undergo division with that particular term that you pick from the denominator. That's what you do there. Then you do simplification when possible. After doing the simplification, those that are still having this thing as their denominators, right, they all tend to 0. And those that are not having, right, you just keep them like that. Now, at the end of the day, we just have 0. Let's look at another question. So this one too, we have to clean this thing. This is from the previous session, that's why. So the positive infinity or negative infinity, we have the same thing. So how do we do this one? The bottom you have x, right? You are not, don't look at the top. Don't look at the top. When you are picking the independent variable, always look at the bottom. So if you look at the bottom, you are having this. So x is what we are picking. So we are picking x to divide each component, both the top and the down. So for the top, I have x squared over x minus 2x over x minus 48 over x. Then the bottom x over x minus 8 over x. When you do that, x squared over x will give you x. So you see it's just x. Then 2x over 2 will give you 2. And this one will give you minus 48 over x, because you can simplify all over. This one will give you what? 1 minus 8 over x, because you can simplify this. Remember, this is simplification is done 10 by 10. After doing the simplification, all those that are having x as their denominators will tend to 0. Remember, this guy is not a denominator. X squared over x is not having x as a denominator. It's just giving you x. X is not a denominator. So this one will maintain it. Minus 2 is not having it. But then this guy will tend to 0, because it is having x as its denominator after the simplification. All over 1 minus 8 over x, which is 1 minus 8 over x is return 0, because this 8 is still having denominator 0. Right? Now, if you do that, let me come here. If you do that, you just have s minus 2 all over 1, which is the same as s minus 2. Now, what's the actual value? Now, after doing the simplification, you see that you got this, right? After you got this, put the infinity inside it. Infinity can become infinity minus 2. Infinity minus 2 is just equal to infinity. So if it is positive infinity, it's going to be positive. If it's negative infinity, it's going to be negative infinity. Infinity over whatever number is infinity, right? Infinity minus 2 is still an infinity number. Negative infinity minus 2 is still a negative infinity number. So yeah, depending on whatever they are giving you. So when we do the simplification and everything tends to 0 and you see an s component that's not a denominator, put the value inside back and then you get an infinity. Let's solve this one too. This one, look at the denominator, which is t. Here our independent variable is t, no more x. You see what I told you? So yes, so in this case we have t. So for that particular time, for this particular case, we have to pick this t squared. Remember, we are not picking this t squared, we are picking the bottom one, t squared. We pick this one. So each term, both top and down, t squared plus t over t squared minus 2 over t squared. Then bottom we have t squared over t squared minus 1 over t squared. When you do that, what do you have? This over this will give you 1. This over this will give you plus 1 over t. This will maintain like that because you can simplify the t. All over t squared over this is 1 minus 1 over t squared. After doing the simplification, all those that are having t or the independent variable as the denominator all tend to 0. Here 1 is safe. This guy is plus 0 because it's still having t. This guy is also going to be 0 all over 1 minus 0. If you do that, we are going to have 1 over 1, and 1 over 1 is 1. So this is the answer for this particular question. Let's solve a last question to solidify the concept. So you go here, right? So in this case, please don't go and take, it's approaching infinity, don't go and take the 3s squared. No, don't pick the entire 3s squared. So far we've solved questions where it was just s squared plus 2 or something, but here it is the s squared is having a component, that's the greatest power, but it's having a constant. Don't take all the 3s squared, just pick the variable, just pick this guy, you just pick this guy. Are you okay? Don't be picking a constant aside beside that. That's why I try to introduce this particular question. So if you do that, we are picking x squared again. So every member, both top and down, right, will all have they undergo the division. We are doing, oh, so it's 8x over s squared. We are doing justice to each of them. So 8x over s squared minus 3 over s squared. The bottom one, we have 3s squared. Whatever we pick it from, we also do justice to that same value, that same term. So if now let's do simplification. 5 s squared over s squared. So the s's will cancel, so you just have 5. This guy will give you plus 8 over x, and this guy will maintain like that during the simplification. Then you go down, this guy will simplify this, you have 3 plus 2 over s squared. When you do this guys, so we have 5 plus 0, because this guy is still having the denominator like that, minus 3 over this guy is still 0, all over 3 plus 2 over s squared is going to be 0 as well. Then at the end of the day, we just have 5 over 3 left. This is the answer for this particular thing. Yes, to find the limit of this is very helpful because it will allow us to find the asymptotes, which we'll discuss in subsequent sessions, right? Limit of functions will help you, that's approaching infinity, right? Help you to know the asymptotic value, which will help us. We will do that in subsequent sessions, right? Stay in touch so that we actually solidify this concept. So solve more questions on this, right? And if you have any challenge, you can put it in the comment section. We'll attend to you.